So good afternoon, all. My name is Gabriel Veloso. I'm civil engineer from Brazil, and I'm glad here to present my master's dissertation, Web3 Services for Information Exchange in the Construction Side, which were done inside the University of Ljubljana under the supervision of Professor Vlado Stankovic. So our main goal here was to build an application that could produce reliable data exchange processes to bring trustworthy to tender processes for construction services and establish workflows for defining information requirements for the build chain project use cases, relying on decentralized technologies. So therefore, we walked through a very thin line, trying not to make the technology aspect more important than solving problems here. And for that, we started gathering requirements through extensive literature review. First, understanding a bit more the information management processes with the ISO 19650. Also, understanding more the IFC schema and the IDS standard from the open mean workflows perspective, and of course digging up on Web3 technologies, considering blockchain and decentralized applications, self-sovereign identities, non-fungible tokens, decentralized knowledge graphs, to understand better what each of these technologies could bring, their strengths, and which one would be better to use throughout this application to bring some added values for the build chain project. So considering the literature review, let's focus a bit more on two topics. First, the information delivery specification. This standard is kind of a kernel for this application. And this standard built by Building Smart provides us a framework to define applicabilities and requirements for information deliverables in a way that is possible to a machine and a human read. And in the end, it becomes an XML file that provides this possibility to structure your specifications. And the next very important thing for this literature review is the build chain project itself. It's funded as a project funded by the European Union and is the main reference for this work. We had the opportunity to interact with this project along the past 6 months, and they aim to produce a BIM-based decentralized knowledge platform and create a new tokenized economy around digital building blocks, building logbooks. So what we aim here is to produce like a pilot to generate frameworks for information exchange, considering the 12 use cases of the build chain project. Therefore, our proposition here is a decentralized marketplace for construction services. And it relies on three main topics: the IDS itself, to define information requirements and generate subsets of data, NFTs to generate a tokenization process and reputation system, and of course the IFC to get the building information, to have an actors database and approval mechanisms. So to build this application, we first developed a business process model considering the three main actors provided by the ISO 19650, the appointing party, the lead appointed party, and the appointed party, considering their roles in the application throughout the 8 project phases. By that business process model, 25 user stories were generated to be implemented, considering since the IFC 3D viewer to the IDS parsing methods, and also the development of the functions for the decentralized application itself. So these 25 user stories can be understood in a simpler way in this system architecture, considering that what we aim here is to generate NFTs based on the IDS files, and these IDS files will parse the IFC to provide only the subsets of data for the actors that will work on this data using an IFC.js viewer. So in our front-end components for this application, we rely on the React technology, and here are the structure of the components. And on the right side, we have the decentralized components that work as a backend. And here we have two decentralized components that are two smart contracts. The first one we call OpenBND and have all the functions to handle their interactions in the decentralized marketplace. And the other one is the NFT itself to retain the information of the IDS file. And this implementation was divided in 4 big steps: the integration of IFC.js viewer and the IDS parsing, which we can see a demo in the video below, proving that the functions were managing to parse the model and show the applicability and the results of the requirements. Then the integration of smart contracts, the front end, and the integration of the ID documents. Therefore, in the implementation, we tried to connect the smart contracts to the IFC schema itself. So basically, in the NFT smart contract, we can get the owner of that smart contract, of that NFT that represents the IDS, and the IDS represents a construction service, and store as an identifier for our organization inside the IFC schema, which can become an IFC actor, and objects can be related to this actor, considering also what is stored on the IDS file. Also, for approval process, we do a similar process considering the IFC approval entity to run approval processes of these construction services. Here, example of the implementation of this process. Always we went back to the express specification of the IFC and built with the IFC.js library methods to write these entities on the IFC schema, which you can see in an example in the middle, and in the end is just a console log of the results of this method. As a study case for this application, we consider a service of concrete walls execution on site. So this study case is divided according to the 8 project phases of the ISO. And first, in the assessment and need, we consider that the client should develop the IDS file. And here on the right side, we can see the structure of the IDS, which the applicabilities are all walls with the load-bearing property as true, so all structure walls. And the requirements are that the compressive strength on site property should be filled. And in the left, we can see the sample of model that was used. So in the process to invitation to tender, the client has the responsibility to generate the NFT that will represent this construction service. So first, he uploads the XML file that is the IDS, gives a specification name, then he has the opportunity to link his IFC model. In this case, we use the Autodesk Construction Cloud, considering the data management API. And then he gives a sort of value for the complexity of this work and make it available on the decentralized marketplace for new bids. And then in the process of tender response, here we just did a very small sample on the contractors responding with a pre-appointment BIM execution plan and responding to this tender. After that, the client has to confirm the lead appointed party. by checking the documentation. And here, at this point, when he presses the button confirm lead appointed party, the ownership of the NFT is transferred for that that contractor that kind of bought the NFT. So now he has the access of the data that the IFC, the IDS express as an applicability for that service. And here now he has the opportunity to update the IFC actors, especially considering subcontractors that will work on site. Then it's the time to execute the service on site, and he will have access to update the properties that were established on the requirements of the IDS file, considering what was obtained on site for the compressive strength. So the last step is to request the approval for the client to give this approval, and then while he's requesting the approval, it's generated IFC approval entity, and also it's linked DID document that express a verifiable credential, considering laboratory tests that proves that the values attributed to the model are real. Then the last step is to give this approval. And here we have the conclusion of the reputation system, where the client gives a score for the execution on site. Establishing here a full reputation system where in the beginning, the client establish the complexity of the construction service, make the NFT available, and in the approval process, it gives a score for this execution. And after this, all this data can goes to the contractor and becomes a sort of a proof of experience for next tendering processes. And to conclude, the results we divided in two parts. First, the usability assessment, where we could show that we could give the right data for the right actors at the right time, especially considering the IDS mechanism using the NFTs and the transfer of ownership. And we could also provide the very easy mechanism to update IFC model properties directly on the browser using the IFC.js library. But we have still a lack of automation in the assessment and need phase, especially to write the IDS file. In terms of effectiveness and scalability, this application is kind of very cost-effective, considering the use of the Internet Computer blockchain. And we provided a very efficient reputation system that can enhance tender processes. Although we still have a lack of automation to trigger the smart contracts, considering IoT data. We could have sensors, concrete sensors to measure the compressive strength and send this data to trigger the smart contract in this case. Therefore, last result that was very positive as well, we could provide a possible approach for the build chain project to use this framework considering the digital building logbooks. And here we have still some limitations. Some parameters of the IDS standard are still weren't fully implemented yet, but there is no actual limitation in terms of the IFC.js library to implement it. And also we have some limitations considering the bean data transfer process. We still rely too much on a file-based transfer, and we have to move to a granular data process to be more efficient. Here, considering throughout this whole presentation, we could highlight some contributions of this work, but also we have a lot of works to do considering all this technology shown in this slide. We have a lot to improve considering identity management, and especially IoT integration to this process to trigger the smart contracts. And also we could easily integrate the BNB Smart Data Dictionary and the BCF workflows throughout this application. Thank you for your attention.